industry certifications and micro-credentials for technology and manufacturing programs. We're very fortunate to have Matt Kirchner from Lab Midwest. He's president of ATS Lab Midwest, former business owner, and a nationally recognized speaker and author. And then joining him is Deborah Dawson-Gunther, or Debbie Dawson, from Montcalm Community College, and James Wall from SACA. So Matt, I'm going to turn it over to you and allow you to do the remainder of the intros and lead with your presentation.
Hey, Jason, thank you so much. It's great to be with everybody this morning. I certainly want to appreciate and recognize your leadership and the leadership of everybody at Northwestern Michigan College. You guys are just doing amazing things. It's so great to be back with the Trends Group. I had the opportunity to keynote this event 2 years ago, and that was a really special day for me. And it's great to be back in front of everybody. So thanks for joining us here on a Friday morning. In just a minute, we are going to be joined by both Jim Wall and Debbie Dawson-Gunther to talk a little bit about SACA. But as we get into that discussion, we are going to tee up this whole concept of Industry 4.0. So you have unfiltered Matt Kirchner here for about 20 minutes before we dive into some of that Q&A with Jim and Debbie. Would you believe that in 1 minute in technology, in 1 minute, every single minute, all this stuff happens? 1 million Facebook logins. We have 18.1 million text messages are sent every single minute. 4.5 million videos on YouTube and elsewhere. 390,000 apps are downloaded. 87,500 tweets go out. We have 1.4 million Tinder swipes. That's a little bit scary for me. 188 million emails. 180 smart speakers are shipped every single minute by Amazon. 41.6 million instant messages. Almost 700,000 hours of Netflix hours are viewed. 3.8 million Google searches. 300 hours of video are uploaded to YouTube every single 60 seconds. And every minute, almost $1 million is spent on the internet. Literally in the 60 seconds it took me to go through that slide, all of this stuff happened on the internet. We genuinely and truly live in amazing times. This is leading us to the fourth industrial revolution, all these changes in technology. Every speaker on Industry 4.0 has their Industry 4.0 slide. Here is mine. We go back to the first industrial revolution back in the 1700s with mechanization and steam power. Then we had the next one in the late 1800s into the 1900s when we started using electricity and mass production and manufacturing. Then we get into the third industrial revolution in the late 1970s, early 1980s with robotics, automation, and computers. And now we are well into the fourth industrial revolution, where cyber physical systems, artificial intelligence, machine learning, smart sensors, smart devices, augmented reality, all of these technologies are totally changing the way that products are manufactured. Now, here's my second Industry 4.0 slide. I love to tell the story of 15,000 robots. Right now, today, there is a major manufacturer in the United States that has 15,000 robots spread across their manufacturing operations. And they've taken those robots and loaded them up with smart sensors and smart devices that are tracking things like moisture, temperature, disturbances, force, and so on, sending that information to a computer network and then to a data collector and then up to the cloud, where all of that information is analyzed in real time. Right now, that company has those robots to the point where they can predict their own future failure and order their own replacement parts before the failure ever happens. And this is true not just in manufacturing, but in healthcare and agriculture, distribution, hospitality. Literally every single corner of our economy is affected by smart technology. So we're going to talk this morning about what I call Infinity 0.0, this idea that we are in the middle of continuous industrial revolution. There will not be an Industry 5.0 or 6.0. This is just going to keep going in real time. Technology is changing manufacturing that fast. And we're going to talk about 4 different areas of Infinity 0.0. Smart sensors and smart devices, informational data, and the amazing careers that will be available to our students and learners in the future, digital twins, and then a little on how education is adapting, all in a way of setting up the special guests for this morning, which are Debbie Dawson-Gunther and Jim Wall, to talk about their involvement with the Smart Automation Certification Alliance. Let's start with smart sensors and smart devices. These are the same things that some people have in their refrigerators that literally can tell you what is in your refrigerator, how long it's been there, and even make your shopping list for you. It's the same technology that smart cities are using to track everything from fire protection, emergency services, water, utilities, and so on. All of this being gathered in real time and sent up to the cloud and analyzed. That's what a smart city is all about. So it's the same technology, but at the very base of all this technology, fundamental to Industry 4.0, are smart sensors and smart devices. Everybody on this meeting this morning has one of these sitting on their desk. We call it our smartphone. Everybody has a smart device, but we have all of these things in manufacturing that are becoming smart, measuring things like air velocity, light, motion, ultrasonics, vibration, water leaks, vehicle detection, smart sensors and smart devices. This is important. There are two things that make a smart device smart. The first one is that it has the ability to communicate with other devices. So it can send information, for instance, using Bluetooth and other technologies to other devices. And second, they have embedded intelligence. They can make their own decisions. And we'll talk in a moment about why this is so important. But before we get to that, we need to understand that smart devices live out on the edge. When you hear people talking about edge computing, edge devices, that's what they're talking about, the smart devices and smart sensors that live out on the edge of our networks. Our networks are what we call the fog. Network can be a computer network. It can be a programmable logic controller in manufacturing, not to be confused with the cloud. Those are these external data centers where all this data is sent, stored, and analyzed. So here's how smart devices are revolutionizing the world of manufacturing. In my world of manufacturing, I spent 23 years as a manufacturing chief executive and chief operating officer. In those days, we took data from devices and sent it to a programmable logic controller. So we had a temperature sensor, for example, that would measure the temperature in a tank, in a room, in a process, send that information to a PLC. The PLC would make a decision using that data and send an action to an output device, maybe a cooling coil to cool down a tank, for instance. So there's two challenges with this model. The first one is that requires tremendous time, what people in the IT business call latency, and bandwidth. And so because of the time it takes to send this information around a network, because of the bandwidth required, we were limited in the number of devices that we could deploy in our manufacturing operations. Now what happens when these can communicate with each other? Now what happens when they can make their own decisions? We no longer have to send all that information to a PLC. We can just gather the pertinent information and send it. And otherwise, everything can happen out on the edge. And this is creating a huge proliferation of smart devices in the world of manufacturing. So not too long ago, I was in the lobby of a great company. We'll talk about them later, Rockwell Automation. And I was waiting for a meeting, and in walks this guy named John Carrier. He is at the Sloan School at MIT. This guy is an expert. He is a whiz at the whole world of smart technology and manufacturing. Now, he happened to know that I ran a private equity-backed manufacturing company for a number of years. He had all kinds of questions about that experience. We talked about that, and then we started talking about smart tech and manufacturing. Here's what Dr. Carrier told me. He said the size of devices, the size of smart sensors and smart devices in manufacturing is decreasing. They're getting smaller and smaller, so we can put them in more and more places. He said he's seen a cost reduction of orders of magnitude, which means that something that was $10,000 is now $1,000, and something that was $1,000 is now $100. And that is exactly what happens. He says today the cost to buy sensors and connect them to an IoT platform is less than $100. It is not expensive to deploy smart technology in manufacturing. It's not a whole sea change that we need to try and figure out how to navigate. We can do this very, very inexpensively, and we can use all this technology. Here's an example of a smart enterprise system that is using smart photoelectric sensors, pressure sensors, ultrasonics, stack lights, position sensors, RFID, smart barcode readers. This is the world of manufacturing, not in the future, but of today. And it's really important for us to figure out how we prepare our students for these opportunities, because there is really cool opportunities in the world of Industry 4.0. You see, the way that we improve processes in manufacturing is totally changing. In my days as a manufacturing executive, if we had a problem that we wanted to solve, if we wanted to improve a process, we would gather a group of people, managers and people from the shop floor around the problem, start talking about it, and it wasn't long at all before we realized that we didn't have enough information to be able to solve the problem. And so we would go out and find somebody that we called an industrial engineer, and we would hand them a clipboard, and we would send them out to the line, and we would have them gather data for a day, a week, a month, as long as it took for us to be able to make a good decision. Folks, the truth of the matter is that in the world of Infinity 0.0, the problem will not be a lack of data, but way too much of it. And figuring out how we discern what we call informationable data from everything else. This is leading to some amazing career opportunities as we look at how informationable data is changing the world of business and manufacturing. I won't go through every one of these bullet points, but believe it or not, most companies only have 12%. They only analyze 12% of the data that they have. They leave the rest of it go to waste. Using big data, would you believe that Netflix saves $1 billion a year in customer retention? They track what you watch, when you watch it, what your tastes are, what your interests are, and they serve up for you exactly the right programming that will meet your interest at exactly the right time. And doing that, they claim they save $1 billion a year. Yes, the amount of data created over the next 3 years is greater than all of the data we have created over the last 30. And that is leading to amazing career opportunities for our students. Not too long ago, a group called Manpower in my hometown of Milwaukee did a study and came up with what the jobs, the careers in manufacturing of the future are going to look like. This is what lie ahead for our students. Chief Digital Officer, Process Simulation Engineer, IT, OT Systems Engineer, Collaborative Robotics Specialist, Instrumentation Engineer, Automated Guided Vehicle Systems Engineer. Folks, this is not our grandfather's world of manufacturing. The careers that will be available to our students will blow them away. Amazing opportunities available to our students in the future in the world of manufacturing. Now let's touch on one other technology. This is the technology we call digital twin. Some of you are familiar with this. Some of you have heard of this. Let's talk about what a digital twin is. Not too long ago, I was in Rochester Hills, Michigan, and I saw this really, really cool display. Now, I made a living owning a company that built paint fixtures for Harley-Davidson and dozens of other huge OEMs for a whole bunch of years. And so I'm fascinated by the whole world of paint and coatings. I'm fascinated by how we fixture parts to be painted. So I was mesmerized by this display. And as I'm looking at this display, the engineer that put it together came up behind me and he said, "You know what, Matt, if you think that's cool, you should see what we have across the hall." And he took me across the hall and showed me this exact digital twin, exact digital replica of that paint operation. Digital twins is just one example of technology that is totally revolutionizing the world of manufacturing. Would you believe that NASA has their own Center for Advanced Manufacturing? I've actually partnered with that group in the past to develop solutions for customers. So here's what John Vickers, who runs that organization, says about the digital twin. He says the ultimate vision for the digital twin is to create, test, and build our equipment in a virtual environment. And not until we have that equipment working exactly the way that we want it to do we build the physical manifestation of that equipment on the shop floor. So we get it working perfectly in the digital world, and then we create the manufacturing process. Okay, so that's the first thing we do. But then the second thing he says is we load this up with smart sensors and smart devices, gathering data in real time, feeding all of that information back to the digital twin. As the digital twin gathers that information, it becomes smarter and smarter and smarter. And now when we want to innovate our manufacturing process, we don't do it on the shop floor. We do it on the digital twin. And here's why that's important. What is the scariest day in the life of an industrial engineer, in the life of a manufacturing engineer, in the life of an electromechanical technician? The scariest day is the day that they go to the shop floor and make a change to the process, because there's a customer on the other end of that process that is expecting parts, expecting good parts to arrive when they want them and in the condition they need them. And if we change that process, we run the risk of changing our ability to deliver to the customer. But what happens now when we take that system, we load it up with all these smart sensors and smart devices and create our digital twin. And over time, the digital twin gets smarter and smarter and smarter. Now, when we want to innovate the process, we don't go here, we go here. And we can test that process and that change over and over and over again until it is functioning exactly the way that we want it to. And now we go and change the shop floor. And what that means is that the rate at which we will be able to innovate our manufacturing processes will increase literally by orders of magnitude. The speed at which we can change manufacturing will change literally exponentially. And that is what is going to happen and is happening already in the world of manufacturing. So now, before I dive in and have a really great discussion with Debbie and with Jim, let's talk about how education is adapting to this world of manufacturing change. What influences a young person's career pathway? Let's think about that for a moment. There was a study that was done not too long ago by Skills USA and the Manufacturing Institute. And they went out and said, what are those things that influence a young person's career pathway? And all of the normal items are on the list. So if we look at the list that they came up with, it's things like your father and your mother and your coach, your friends, other media. All of these things are on the list. But would you believe that the number one influencer of a young person's career pathway, and it isn't even close, are their own interests and experiences when they're in middle school and high school? And that's why we say, if you go into your local high school, you go into your local middle school, and their manufacturing and technical education programs don't look like this, that is the reason that they can't find people. That is the reason that your industrial employers can't find people, because you're not inspiring these young people toward these amazing, amazing careers. Now, fortunately, this is all changing. Fortunately, thanks to introductions of programming at the high school level, introduction to mechatronics, introduction to industrial controls, robotics, IIoT. We have schools all over the Midwest and all over the United States that are teaching these kinds of courses in high school to high school students. And that is inspiring those students towards careers in advanced manufacturing. This is really, really important work that is being done. Schools all over the country are teaching these courses, and it is really, really good news for the world of advanced manufacturing and for the students that will be going into these amazing careers that we've already spoken about. Now, the question is, how do we prepare these students for these careers, and how do we certify that they have competencies that are industry relevant and that are backed by industrial employers and are recognized by industry when those students get to industry? So right before I introduce my very, very good friend, Jim Wall, I'm going to mention that I'm getting a little bit of audio coming from somebody's mic. So if you're not speaking and you're on the panel, if you can mute out, that would be great. And I am at this point going to introduce my very good friend, Jim Wall, the Executive Director of the Smart Automation Certification Alliance, to our audience this morning. Jim, thanks so much for being with me.
Oh, good morning, Matt. It's great to be here.
I'm really looking forward to this discussion. You're doing so many amazing things at the Smart Automation Certification Alliance, and we're going to give you an opportunity to take credit now before this audience at Trends for all the really good work that you, your industrial employers, and all of the members of the Alliance are doing. I want to start out by, just in case we have people on the call this morning that aren't familiar with what a certification is, Jim, can you take just a moment and explain what is a certification?
Well, our certifications are based on an industry agreed upon standard of, the standards outline what it is that the industry expects a person to know and, more importantly, be able to do. So we develop a certification program to assess an individual's skills against that standard. So in our program, we have both cognitive assessments, written knowledge tests that we deliver online through in a proctored environment, and also have the opportunity for individuals to do hands-on performance assessments so that they can actually prove that they can use the technologies effectively.
Perfect. And I'll note for our audience who are looking at the screen that what you have there on that screen, and I'm really proud of this. I've actually earned 2 of the certifications that Jim and his organization have put together, one in advanced operations and one in basic operations for Industry 4.0. Really, really proud of those certifications. I earned those over the course of COVID when I was confined to my home and spending plenty of time on e-learning, and then going through the certification exams to earn my silver SACA certification. So, there's one of the things I always like to mention, Jim, when I was in the world of manufacturing, I be honest with you, I really didn't know what an industrial certification was or a third-party certification was. I knew about a couple of them, but didn't know that all of these existed. Then I get over to education about 6 years ago, and there's literally hundreds and hundreds of these things. Tell us, in this whole sea of certifications, what is it that makes the Smart Automation Certification Alliance unique?
Well, I think the most important factor that makes us unique is the broad industry involvement that we've had. All of I mentioned earlier, our standards, which is what our certifications are based on, are 100% developed by industry experts that come together and come to consensus. And then, those draft standards go out for validation, both nationally and internationally, with hundreds of additional industry folks weighing in. And, I think that's sort of unique that it actually is developed and validated by industry. It's not, there are a lot of other certifications out there that are vendor driven, or they're around someone's specific technology platform or their equipment, and those are fine. But we think it's important to have an industry standard where the industry comes together as a whole and comes to consensus on these are the things that are going to help a person in their career path.
I love the way that you've gathered so many great industrial employers together. I know we're going to talk about that in just a little bit. For our audience today, on the 2nd of November, I know you're running another your first process control certification technical work group. So if we have industrial employers that are interested in serving on that technical work group, or for our educators that are on with us today, if you have industrial employers that are in your orbit that you're working with now that want to be part of that process control technical work group, certainly reach out to Jim, and I know we'd love to have you along for that ride. As I mentioned, we are going to talk a little bit about how you identify skills and competencies. You alluded to this a little bit in your last answer, Jim, but as we put up a slide of so many of the great organizations that have been involved with you along the way in creating these certifications, tell us how you identify skills and competencies.
Well, we form what we call technical work groups, and again, these are voluntary groups that companies volunteer their technical experts to be part of. And the slide you show actually represents the participants in our first technical work group and validation meetings that began back in 2017. And I think you can notice that we make a real attempt to get various industry sectors represented. And we think that's really important, because we want to have an industry standard that really truly does represent a whole cross section of the industry. So this slide shows additional companies that have come on board since the first technical work group, and again, you'll recognize a whole slew of different industry sectors, from aerospace to food processing, medical device, just a whole gamut of industry sectors. And that, I think, really does add credibility to the standard that it is applicable nationwide.
It adds credibility to the standard for sure, and I think also adds a degree of demand for your certifications on the part of these and other employers. What better way to have an industry certification recognized by industry than to have the industrial employers involved in the actual creation of those standards? So credit to you. What a novel idea to go out and, when we're creating a certification around Industry 4.0 competencies and want to figure out what employers actually want when they hire and employ these people, to just go out and ask the employers. So it just makes tons and tons of sense. But I know it took a lot of work to put these groups together, Jim, and just incredible credit to you and to your team for assembling a really, really impressive group of industrial employers that are supporting the work you're doing. And that group, by the way, continues to grow as more and more companies become interested in the great work that you're doing. Another thing that I think makes you unique is the way that you've set up your financial model, and ensuring that as you're creating a recurring revenue model, as you're creating a sustainable business model, you're really not leaning on the student themselves to make sure that you're able to sustain your organization. You've come up with a pretty interesting way of funding all the great work you're doing. Why don't you tell our audience about that?
From our inception, we have a goal to develop the standards and the certification and have quick adoption, so we get people with the certifications into the workforce. And we recognized early on, if we could take the financial burden away from the individual student or the employee, that more people are more likely going to go through the certification process. So we from our inception, made a decision to have our certification process be free to the individual. We do that by operating on a membership basis. Schools and companies can join the Alliance. And once they are a member of the Alliance, they have the ability to offer an unlimited number of certifications to their students or employees. And we try to keep those membership costs as affordable as possible. You know, it starts at $500 a year for a high school program. For a college program, it's $2,500 a year for the college. For the industry memberships, begin at $500 for a company of 100 or less employees. And then there's a scaling rate that maxes out at $3,500 for a company of 500 or more employees. And that's the certification. There's no per certification fee. It's a one-year membership that provides that ability to offer the certifications in the organization.
So for example, if a high school is a member and that's $500 for that high school, and they're certifying 100 students as an example, those certifications are literally like $5 a piece per student on a per student basis. Am I understanding that correct?
Absolutely.
Yeah, and when you think about being able to issue a certification for $5 to a student, that just is the way this is supposed to work. You want to have these certifications in the hands of the students. You want the employers to recognize them when they get there, and we want to make sure that as you're creating a sustainable business model, and as one of your board members, obviously that's really important to me, that you're doing it in the way that isn't leveraging the student themselves. Very, very impressive model. So you've got a number of different certification levels, Jim. I think this is another interesting aspect to the way that you've created the Alliance and the way that you've built your certification model. Why don't you talk a little bit about what those levels are and how they're leveraged by your members?
Sure. We have 3 different levels to our standards and certification. The first being an associate level. These associate level certifications are designed to really focus on the foundation level skills that a person should have if they have a reasonable understanding of an advanced manufacturing environment using Industry 4.0 technologies. These associate level certifications aren't necessarily designed for any particular occupation in particular, but really, focusing on those foundational skills that could be applied in really any occupation going forward as we transition to more involvement in the Industry 4.0 technologies. We have a specialist level certification, and these specialist level certifications are designed around specific occupations. And at the specialist level, each of these occupational certification is made up of a series of individual micro-credentials. These micro-credentials can be stacked different ways for different occupations, for different purposes. And the specialist level are really looking at the technician, technologist level skills. And then the third level would be professional level. And here, the professional level is looking at the engineering and optimization of Industry 4.0 systems as a whole.
I think it's a really interesting way that you set this up. I served yesterday on a panel in the state of Wisconsin. We talked a little bit about SACA, and one of the questions from the audience was around stackability. And I think that's the other thing that you've done just a really, really great job here is all of these are certainly stackable. You don't necessarily have to earn one in order, so you can jump in anytime, but it really creates a nice pathway. And by the way, a nice platform for standardizing competencies across high school programs and community college programs, especially in states like Michigan, where there isn't a statewide requirement as far as how we're teaching and delivering these competencies, that we really have a decentralized model. This model that you've created with these different certification levels lends itself really, really well to a decentralized education model, such as the one that we have in the state of Michigan. I think another thing that you've done that's really interesting is created these micro-credentials. And why don't you just cover a little bit for our audience, what is a micro-credential and how does that then lead into some of your specialist credentials and professional credentials?
Well, the whole concept for us to use micro-credentials came out of our very first technical work group meeting when we had the industry experts trying to visualize what kind of system would work within their own companies and their own organizations. And overwhelmingly, the response was, we really need a system that's very modular and granular, that we can do in small chunks. And they said, if we could send people for training or conduct training for a week at a time, that really would be ideal for us to be able to upskill our existing workforce. So we use that rule of thumb to try to size the content of each of these micro-credentials so that conceptually the individual could go through that roughly 40 hours or less of training and get the training and go through the certification program and get that individual micro-credential. And then over time, those micro-credentials could be stacked together either in an occupational certification or, for an incumbent worker, if their company's moving into smart technologies, they might, just do some short-term training around smart sensors or smart factory technology and get that certification and advance in their career. Other folks, especially in education, could stack these credentials together to get an occupational certification that, hopefully will provide them labor market advantage.
Great answer. And what I would mention really a couple things. The first one is one of the most challenging things that I do in my job and that our team does is working with community colleges to try to do that bridge or crosswalk between what's going on in their programs, the outcomes for their individual courses, and what is in a certification. And one of the things that these micro-credentials augment really, really well is our ability to just crosswalk from course to course as we look at competencies. So that's a really, really good application of these. The other thing, to your point, Jim, in our work with industrial employers, it's amazing how many of them will come to us and say, we just want our people to have a course on programmable logic controllers, or we just want somebody to learn a little bit about basic hydraulic troubleshooting. And now you've got a micro-credential that we can tie that to. And we can say, okay, these are the competencies within PLCs that we're hearing from industrial employers they want their employees to know. And now you've got a model to, once they've gone through whatever the education pathway is to get them there, to be able to establish that they've got those competencies. So really brilliant foresight on your part in that regard. And you also mentioned, and I want you to go a little bit more deep into this, Jim, the idea of tying these to specific occupations. And I know in the last 12 months, you've done quite a bit of work in that regard. Tell us about that.
Right. So, we've worked and we've talked for a long time about how stackable credentials could be used. But, we've through our website have shown people how the different stacks of micro-credentials could be used in various occupations. So on the screen there, you see the Industry 4.0 electrical systems specialist, and it's made up of a number of credentials. There's one credential and several micro-credentials, and once people see that this and related to different occupations, it really does provide a spark, especially on the industry side, for folks to see, so these micro-credentials can be used different ways within our own organization with different occupations. So it really has helped people understand that whole concept of stackable credentials and how it can be related to an occupational career path.
Just another example of the creativity that you continue to employ at the Smart Automation Certification Alliance, Jim. I know that's attracted tremendous interest on the part of industrial employers. We've talked about that already, but there's one employer that I think is probably pretty recognizable to our audience in the form of Rockwell Automation that has specifically stepped up and supported your work at SACA. I want you to share with our audience, not too long ago, you made a really, really big announcement about Rockwell's commitment to the Smart Automation Certification Alliance. What should they know about that?
Right. We are really happy that Rockwell made the commitment and stepped up and to become a platinum sponsor with the Alliance. Rockwell was involved really from the very beginning with our first technical work groups, and they continue their involvement as we've progressed over the years with additional work groups. But about a year and a half ago or so, they recognized that they wanted to do more to help get the word out about these new standards and certifications, and they've made a commitment. Obviously, they made a significant financial contribution to support the Alliance, but I think more importantly, they've made a commitment to use their influence in the industry to get the word out to their supply chain and their customer base that these standards and certifications are available. And really the whole goal of our partnership is to help develop additional pathways for individuals, whether it's, high school programs, middle school programs, community and technical college programs, university level programs, and also on the workforce development side, company training programs. There's a real need to have additional pathways for individuals to get these skills and either get into these new occupations, or for folks who are working in the industry to upgrade their skills and stay current. And the whole goal is to have a workforce that is really intelligent around the Industry 4.0 technologies, so that we have a really productive workforce, and that's going to keep American companies competitive.
It's really a great example of how we build amazing partnerships. Here in the Midwest, where I live, and I know our audience lives as well, it's one thing for somebody to shake a hand and say, we support you, and that's really, really important. It's another thing for an organization to put their money where their mouth is. And that's exactly what Rockwell did in this particular case. I'm not going to disclose the amount of the check that they wrote to the Smart Automation Certification Alliance, Jim, but it was a significant financial commitment on the part of Rockwell, which I think really, really speaks to the confidence that a great company like they have in the work that you're doing. So congratulations to you once again on a really, really solid partnership. I want to talk just a moment. I know as COVID set in, you came up with a creative relationship and a creative idea, I guess better said, to be able to flex with the fact that we were having challenges with in-person learning. Tell our audience, as we kind of close our time with you before we move over to Debbie, about your silver and gold certifications.
Well, we, as you said, when COVID hit, really faced a real problem. We had, a number of schools and colleges around the country that were in the midst of training programs with the goal of incorporating the SACA certifications, and when everything went virtual, we decided that it really made sense to separate our credentialing program out into two levels. So we developed a silver level certification and a gold level certification for all of our credentials. The silver level is available to individuals who successfully complete a written knowledge assessment that we deliver online through the SACA testing portal in a proctored environment. And the gold level certification is available to individuals who complete both the written knowledge assessment and the hands-on performance assessment on real live equipment. The nice thing about this system is if someone does the silver certification today, at any time in the future when they can do the hands-on performance assessment, they can upgrade that silver certification to the full gold certification. And although this was done, as a result of the COVID crisis, the overwhelming response from both our industry members and education members is that this really made sense, and we've made it a permanent part of our certification program going forward.
Flexibility is the name of the game in the world of certifications, Jim. And you've had so many great examples of how you've been flexible in setting up this organization, setting up the Smart Automation Certification Alliance for the benefit of industrial employers and for the benefit of educators and their students. So I want to turn our time now over to Debbie Dawson-Gunther. We're going to chat a little bit with Debbie as I invite her up to the stage. I have to tell you that, in my job at ATS Lab Midwest, I get to work with educators all over the Midwest and literally all over the United States. And I know an innovator when I see one. It's been such a pleasure to get to know Debbie. I've been forever indebted to my friends Paul Augusta and Chris Roberts for the introductions. My colleague Alex Hobson and I had the opportunity to visit Debbie at Montcalm Community College earlier this year. Really, really fascinating things going on there. And Debbie, I want to begin by thanking you for your leadership and your support of the Smart Automation Certification Alliance and for your willingness to innovate. Thanks so much for being with us today.
My pleasure, Matt. Thank you very, very much. It's been exciting to be a part of, at least we're a smaller part of a huge organization that's going to continue to grow and help manufacturing down the road. So it's very cool.
Well, and you need to give yourself a little more credit because you have been a huge part of the great work at SACA, and we're so very appreciative of that. I want you to begin by just chatting with our audience a little bit about how you see education supporting the effort with the Smart Automation Certification Alliance.
Thanks, Matt. We were very fortunate to be part of one of the pilot groups that went through with SACA. And when we looked at the certifications, Matt, both you and Jim talked about the micro-credentials. And when we have our students coming to us, usually the employers are sending them. A lot of our students are apprentices. So the employers have said, okay, we need this set of skills. So we don't need a credential that might be down the road that encompasses a lot of different things. Those micro credentials were very effective when we tried to align our curriculum with something that our students could walk away with. So we put our classes together. They are aligned with certain micro credentials. We don't need all of them. If an employer needs one of them, we can certainly put that in place. But we've been able to align our curriculum so that we have the ability to say, you know this information, you prove that you have this information. And it also helps us when we are trying to give credit to students, because we have students who pass different certifications. If we have that alignment in place, then we can say, all right, we're going to give you credit for this class because you have proven that you know the information. So it's exciting for us to be able to do that to help students advance.
And I love your use of the word alignment in so many different ways, whether it's aligning a student and giving them credit for prior learning, or to your point, I'm so glad you brought up the micro-credentials and aligning those micro-credentials to individual courses and even in some cases, individual competencies within your coursework at Montcalm Community College really shows and emphasizes the flexibility that SACA has in terms of working with customers and clients. Speaking of flexibility, these certifications aren't just for students that are going through traditional education pathways, but they're also phenomenal, are they not, for the incumbent workforce? Tell us how you see the SACA certifications fitting with your work in workforce training.
So we have a lot of companies are in our area who are crying for workers, as everywhere. So as we can identify students that come in that may not say, I want to go into manufacturing, we can expose them to the concepts, we can get them some of the micro credentials, and then industry, when they start to hire them, they can walk in the door and they know what skills they have. So we had some workforce training. So from our companies that come in and say, we need to advance some of our folks and just give them some more information so they can move on to other roles. They came in for very specific training. When we looked at the skills that they wanted, it's like, well, if you do X, Y, and Z, then we can get you a credential so that when your students leave us, they're able to walk away with this and prove it to you, not just that they sat in the class for 40 hours, but they understood the material and they know how it works. So it's been actually pretty exciting to see that. We have our industrial advisory committees also who were, instead of doing silos, because a lot of these micro credentials will start to cross disciplines. So we're combining all of our advisory committees. It's an experiment. We'll see how it works, so that they can feed off of each other and see what each other is doing.
Yeah, it's interesting to watch those advisory boards, and I serve on a number of them across the Midwest, and it's amazing the important influence that they provide to our community colleges and our technical colleges all over the United States. Really, really important work, and so credit to you for bringing them into this discussion. By the way, we're always happy to get in front of advisory boards, and I do quite a bit of that. I know Jim does as well, to help familiarize them with what the Smart Automation Certification Alliance is doing. The other thing I love is your reference to that employee, that team member who earns a credential. So in as much as it's important for them to establish with their employer that they had earned that credential, it's also a sense of pride, and we've actually seen it with these employees who earn the credential, earn the certification, hang it in their spot, their workbench, or hang it somewhere near their area of work and take credit for that important work that they've done. We're getting close to 9 o'clock here Central Time, 10 o'clock Eastern Time, where I know our audience is. Talk in the moment that we have left here, Debbie, about the statewide alignment and how you see SACA fitting in across the state of Michigan.
Actually, so thanks. I'll talk really fast, like I don't anyway. But mechatronics at the high school level is currently going through a revision of their skill standards. They're reviewing them. And whether we're at the associate level or if they specialize more, those are areas where we can tie those into our classes at the community college and either offer them additional work that they can do for those credentials, or we can offer them credit for it. So we, again, with that skill set, we know what's happening with it. So I'm excited to see that happen. I want to watch what happens with that. And I have been participating in some discussions regarding that. So again, whether the institution chooses to do the fundamental level or specialize, I think it's going to fit great with the SACA certifications, again, to prove what they know.
Excellent. Great overview on the whole world of alignment and on the topic of alignment. It looks like we have perfectly aligned our discussion this morning with the 45 minutes that we had allotted to us. I want to thank, first of all, Debbie Dawson-Gunther, just a great leader in the world of community colleges and technical education, for being with us. Certainly Jim Wall, the executive director of the Smart Automation Certification Alliance, for all of his hard work and for a great discussion this morning. And most of all, thanks to our audience for spending some time with us. We hope you enjoy the rest of your conference, and it has been wonderful to be with you this morning. Thank you.
Thank you, Matt, Debbie, James. That worked really well. So perfect timing, perfect segue. And then if we get any specific follow-ups, like Debbie, I'll send them your way. If it's, somebody want to know about your implementation, and then, Jim and Matt, depending on what they're looking for, either to you, Jim, or to Matt, like to Chris or Alex or whoever, is the appropriate representative for that area. So
Perfect, Jason.
Thank you very much for doing that.
Thank you.
Absolutely. Thanks for having us. Yeah. Great job, guys.
I'm glad you could do it. And next year it's back in person, so it'll be great.
I look forward to it.
Me too.
Yeah. See you guys.
Thanks. And it's earlier too, so it won't be a problem with NSF. So that works for us.
Oh, that's really good. Yeah, Montcalm was bad, or Monroe was having the same issue, Debbie. So I'm glad.
Great. Cool.
All right.
Thanks, everybody.
Thanks, everybody.
Good night. Have a great weekend. Matt, enjoy your kids.
You too. Bye-bye.
See ya.